What is this place? What is this place? What is this place?
Alright, I think we're all set. Get the volume to the right level, and I'm a little discombobulated because daylight savings time kicked in this weekend. So, a little tired, but I'm ready to go. Let's see. There was a million things to do before I actually start streaming, and I always forget half of them. Let's switch over here. Pop up my pop-up on my other screen, and we should be good. And I missed some chats already. Arvo, hello, good morning. Good morning from Brazil. Nice, I'm on the east coast of the US, so we're on opposite hemispheres. Neat. Let's see, so what were we going to do? We were going to switch back to crafting interpreters. Right, we're up to 9.2 conditional execution. So let's go over there. Make sure we're all clean, ready to go. I think we are. Okay. Yeah, so what we did last, or 2 weeks ago, I guess, on Friday, was we went through, oh yeah, we skipped over the whole Turing machine discussion. And git log, where were we? Well, this says we did while loops already. And we just haven't done if statements. Okay. Git show head. I just have to re-establish. Yeah, there's if already. Okay, what am I doing? Logical operators, we did that. How did I lose track of where we were? There's while loops. Oh, okay, so we're up to for loops. I'm sorry. I've forgotten half the stuff I've done already. All right, so we did logical, we did if, logical, and while, and then we just have to do for loops. All right, git show head. There's nothing else in here. Git diff. We're all clean. Git status, and we're all up to date with our. All right, so let's go over here just to pull this up. So we have this ready also. All right, so this week we're going to work on for loops and then whatever the next chapter is. And there is one other thing I wanted to take a second look at in the interpreter is we have this monstrosity here, a ref cell RC ref cell, which is requiring us to do is double borrow every time we want to access the environment. And the reason I added this extra ref cell was to avoid the infinite looping that was being introduced when I did a replace. So it would be really nice to clean that up. I just don't know how. So I maybe need to play with that offline and then as a in a test environment or in a test workspace, and then see if I can use that knowledge to update the real code. All right, so meanwhile, let's take a look at for loops. We're down to the last control flow construct, ye old C-style for loop. I probably don't need to remind you, but it looks like this. Yes. Most modern languages have a higher level looping statement for iterating over arbitrary user-defined sequences. C# has for each, Java has ANS for, even C++ has range-based for statements now. Those offer cleaner syntax than C's for statement by implicitly calling into an iteration protocol that the object being looped over supports. I love those. For Lox, though, we're limited by building up the interpreter a chapter at a time. We don't have objects and methods yet, so we have no way of defining an iteration protocol for the for loop that the for loop could use. So we'll still stick with the old C for loop. Think of it as vintage. The fixie of control flow statements. What's a fixie? Oh, a fixed gear bike. Yeah, okay. All right. This is what it looks like in grammar ease. You have a for, open brace, variable declaration or expression, then an maybe expression, and then maybe another expression with a close, and then a statement or a block of statements. So inside the parentheses, you have three clauses separated by semicolons. The first is the initializer. It is executed only exactly once before anything else. It's usually an expression, but for convenience, we'll also allow a variable declaration. In that case, a variable is scoped to the rest of the for loop, the other two clauses, and the body. So these two clauses and the body are this variable is scoped to. Once the for loop ends, you lose it. Next is the condition. As in a while loop, this expression controls when to exit the loop. It's evaluated once at the beginning of each iteration, including the first. If the result is truthy, it executes the loop body, otherwise it bails. The last clause is the increment. It's an arbitrary expression that does some work at the end of each loop iteration. The result of the expression is discarded, so it must have a side effect to be useful. In practice, it usually increments a variable. Any of these clauses can be omitted. Following the closing parentheses is a statement for the body, which is typically a block. Okay, so now we're going to talk about desugaring. That's a lot of machinery, but note that none of it does anything you couldn't do with the statements we already have. If for loops didn't support initializer clauses, you could just put the initializer expression before the for statement. Without an increment clause, you could simply put the increment expression at the end of the body yourself, or you'd have to repeat it before each continue. I don't know if Lox supports continue. In other words, Lox doesn't need for loops, they just make some common code patterns more pleasant to write. These kind of features are called syntactic sugar. For example, the previous for loop could be rewritten like this. This delightful turn of phrase was coined by Peter J. Landon in 1964 to describe how some of the nice expression forms supported by languages like Algol were a sweetener, sprinkled over more fundamental, but presumably less palatable, lambda calculus underneath. Okay. This script has the exact same semantics as the previous one, though it's not as easy on the eyes. Syntactic sugar features like Lox's for loop make a language more pleasant and productive to work in, but especially in sophisticated language implementations, every language feature that requires back-end support and optimization is expensive. We can have our cake and eat it too by desugaring. That funny word describes a process where the front end takes code using syntax sugar and translates it into a more primitive form that the back end already knows how to execute. Oh, how I would wish the accepted term for this was caramelization. Why introduce a metaphor if you aren't going to stick with it? Okay. Baking sugar turns into caramel, right? We're going to desugar for loops to while loops and other statements the interpreter already handles. In our simple interpreter, desugaring really doesn't save us much work, but it does give me an excuse to introduce you to the technique. So unlike previous statements, we won't add a new syntax tree node. Instead, we'll go straight to parsing. First, add an import we'll need soon. Okay, we don't need to add imports. Like every statement, we start parsing a for loop by batching its keyword. Okay. So we're not creating a for. In other words, we're not going into here and adding a for in our, oops, don't change anything. In our syntax, in our statement syntax, we're just going straight into the parser and I'm going to figure out what to do with the for directly. All right, this is an fn statement. There it is. So we have, oh, I guess this is right at the top here. If self is match token type for return self for statement. Okay, here's where it gets interesting. The desugaring is going to happen here, so we'll build this method a piece at a time, starting with the opening parentheses before the clauses. All right, so we can start right here. For statement. All right, so we're going to start by consuming a left paren. Expect this after a for. Question mark, right? More here. The first clause following that is the initializer. So we're going to create an initializer and it could be null. So we're going to make it a sum versus a none. Right, because if we match a semicolon, let initializer I forgot that. There we go. Then it's none. Else, it's going to be some self-var declaration. I think that takes a question mark. Oh, that's if it matches var. If match. Then it's a var declaration, otherwise it's some expression. Self-expression statement. Oh, no semicolons there because we're returning that in the initializer. Okay, so if the token following the open paren is a semicolon, then the initializer has been omitted. Otherwise, we'll check for a var keyword. Hello, Zeta numbers. Good to see you. We'll check for a var keyword to see if it's a variable declaration. If neither of those is matched, it must be an expression. We'll parse that and wrap it in an expression statement so the initializer is always of type statement. Previous chapter I said we can split expression statements and index trees into two separate class hierarchies because there's no single place in the grammar that allows both an expression and a statement. That wasn't entirely true, I guess. Okay. Yeah, but we get an expression statement, so we save ourselves that way. Next up is the condition. Condition also can be null. So let's do that. Let me separate these guys out. If not, self check. There we go. Then I guess we could flip it around, right? We can say if this is none, otherwise it's, wait, if not, semicolon, right? If it's a semicolon, return none. So we'll use the same pattern here. Zeta number says, I'm pretty sure this is not a roguelike tutorial. You're right. This is crafting interpreter. So I flip back and forth. Last week I did the roguelike. The week before that I did crafting interpreters. And next week I'll get back to the roguelike. It's still here. It still works. It still runs. We still have this neat little blinky thing. Oh, I gotta fix that so that it doesn't, it clears it out every time we restart it. But that's a bug for next week. Oh, the title. Oh, yeah. I'm sorry. There's always something I forget when I start. So we're not doing roguelike tutorial. We're doing crafting interpreters. And I guess we'll just put in control flow here. Sorry about that. Boom, 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 boom. There we go. Thanks for letting me know. I totally forgot. Do you have a link for the page on the roguelike? I want to build something like that myself. Yeah. So do you want this guy here, or do you want my Epic Blog says came for the roguelike tutorial, stayed for the interpreter crafting. Yay. Yeah, I can give you the link for the roguelike tutorial, or if you want a link to my copy link address, I can give you a link to my GitHub. And there we go. Netic says I'll take both. Why not? Yeah, what we can do is alternate chapters. That would drive me insane. You could watch me slowly go mad on stream. That's why I go week by week, because 1 week's worth of work seems to do the trick. At least for my brain. All right. Where was I? Oh yes, we were doing the condition statement. So we're going to say condition is going to be equal to self-expression, like that. Again, we look for a semicolon to see if the clause has been omitted. The last clause is the increment. Oh, we have to consume the semicolon. We didn't have to consume it here, right? Because we did open paren, we did the initializer. We said if it's not a semicolon, we have an expression, and then we have to consume that semicolon. This consumes the semicolon here. I guess we don't have to worry about, whoops, doing syntax checking on that. And then we have the increment. The last clause is the increment, so we can do the same thing. Let increment equals if self check. And it's none. Otherwise, it's going to be self-expression. Okay, that seems pretty straightforward, right? It's similar to the condition clause, except this one is terminated by the closing parenthesis. All that remains is the body. And then we just return the body? That's not much of a for statement, right? We got to be doing something else. Let body. And what are we doing with all the other things? This is going to give us some errors because the form should be for. The for statement exists. Oh, I misspelled it, that's why. Okay. The paren. This like this, right? Got it backwards. There we go. Declaration. Wow, I'm typing really well. I'm going to blame it all on daylight saving time. All these typos. If and else have different. Oh, this has to be some. And this has to be some as well. Okay. Let's see how that looks. We have 5 warnings. And it's probably because we're not using these guys. And then the extra warning. Oh, good. We caught one. 96. Got to put a question mark there. Okay. Yep. Okay. So that's the 4 warnings I was expecting to see. All right. We've parsed all the various pieces of the for loop, and the resulting AST nodes are sitting in a handful of Java local variables, right? Initializer, condition, and increment. This is where the desugaring comes in. We'll take those and use them to synthesize syntax tree nodes that express the semantics of a for loop, like the hand desugared example I showed you earlier. The code is a little simpler if we work backward, so we'll start with the increment clause. Okay, so now we're going to have this situation here. We got this, and we know whether or not it's a none or whatever, but we're creating a brand new block statement. Yeah, increment. We can just put it in here. Except we can't because we have to get it after the body. Right, because we have to do this. Then body on this has to be mutable. Body is equal to statement block statement. And then it's an array of body and statement expression. Expression statement. Let's look at another example of this so I know what to put in there. That's just expression gets the increment. And a block statement is just the word statements. And maybe that's like that. I don't know. What does self block return? It returns a vector of statements. So we can maybe have to say vec like that. Right? And then we can close this out like this, close that out, and that's body. Let's see if this builds. It built. We got 3 warnings. So now we're down from 4 warnings to 3, which is good. So that did the trick. Epic Blarg, sorry, random question. Do you have a favorite bug to debug? I'm putting together a tutorial on debugging using LLDB with Python script breakpoints, but I need to write a buggy program which makes sense to run a debugger on. And all I can come up with is indexing out of range, which is hopelessly boring and trivial to find in Rust code without the debugger. That's a great question. So my day job is writing kernel software, and the kind of bugs that we'll typically run up against and hopefully find and fix right away are the ones where we're not doing locking properly. You grab a mutex and you mutate some data, and then you unlock the mutex. There's sometimes bugs where you grab some data during an initializer, like just to give an example, since this is C codes like int whatever, and then you have an initializer at the beginning like int foo equals my dot value, and then you do mutex lock and mutex enter. And then you look at value. I can't even type. Look at foo and do something. And then realize then my dot value is equal to the result. And then exit mutex. Right? You've grabbed the data outside the mutex here, and now you bring a copy of it in here. I've seen this bug more than once. Right. Yeah, so deadlocks are good. That's another kind of issue where you have you out of order thing, where this guy's doing 2 different, so enter mutex 1, then enter mutex 2, and then we exit 2 and exit 1, but another function does it in a different order, right? Where function 2 in other func does enter mutex 2, then enter mutex 1. something and then exits here, right? That would, this introduces deadlock when you don't do correct order of locking. That's, yeah, you put me on the spot, man. I don't know. I can probably think of things during the day, and then maybe tomorrow I can put something up here in the chat. Yeah, I mean, obviously there's dozens of different kinds of bugs. Yeah, and as Zeta says, the best kind of bug is the one that doesn't exist. Epic Blog says, this is exactly what I needed. Need to break out of my index out of bounds mental loop. Yeah, no problem. Yeah, and if anybody in chat has any ideas for Epic too, please feel free to jump in. I'll probably think of others while we're typing, hopefully. All right, so we did this, and what's bugging me, of course, is the fact that we set it up here and then we check it here. In Java, it's not as bad because you're just saying, if it's not null, then do this. But we set it up as an option and then destructure the option right after this. It just feels weird. I'll have to think of this. This is going to bug me all day. If there's a different way we can approach this issue. The increment, if there is one, executes after the body in each iteration of the loop. We'll do that by replacing the body with a little block that contains the original body, right here, followed by an expression that evaluates the increment. So we execute the body, then we execute the increment. And if Lox has continue statements, it would have to do the same thing. But we haven't gotten there yet. If condition is equal to null, condition equals new expression literal true. Next, we'll take the condition and the body and build the loop using a primitive while loop. If the condition is omitted, we'll jam a true. Oh, okay, so that's what that's doing. So now we're going to do it the other way. If let some cond equals condition. So we're doing the exact same thing. We're just doing it in reverse here. Then body is equal to statement while statement. And again, we'll take a look at where the other while statements are. It just keeps the condition in the body. Condition cond and body. Like that. Else. Oh, I see. The condition is going to be true or not. The day person, thank you for the follow. So we can just shove this right in here, right? Because we need to say if it's a literal, either it's a literal true or it's the condition that we took. If let some cond. Boink17 says, what is this? This is crafting interpreters being ported from Java to Rust. I hope that's what you came for, because that's what we're here for. Let some cond. Oh, I have to set it equal to condition. So if condition exists, then we're going to say condition. Else, this is going to look weird, isn't it? We'll create a brand new expr literal expr. And the way that works is we have value, some object, bool, true. And then we close the condition, and then that's the end of that part. Arsulin, thank you for the follow. So we have this closing that, we have this closing the while statement, right? Because this body is part of the while statement. Then we close this thing. And that's it. Maybe if we line, I'm trying to figure out how to line this up so it doesn't look so horrible. Yeah, if we do that, and then that, maybe? Ah, that still looks bad. Let's see what cargo format does. Oh, okay. Oh, expected struct box found statement. Oh, interesting. So we didn't need to box these guys in the block statement? Oh, yeah, look at that. Okay. So, but we do need to box it here. Okay. Yeah, I missed something. That's the else for the condition. That's right. Oh, body. Right. Okay. And now we're down to 2 warnings. Routine B says, hello. Good to be here again. Just came home from a dentist, so it was a perfect chill thing after. Oh, good. Hopefully your teeth are nice and shiny clean now. All right. So we did this, and so next we'll take the condition and the body and build up the loop using a primitive while loop. If the condition is omitted, we jam a true, that's this thing here, to make an infinite loop. All right, so we just jam this true in here into the while. All right, this works. Epic Blog says, what song is this? This is, here, I'll put it in chat. I wish I could copy and paste it directly from Pretzel Rocks, but I don't see a way to copy and paste it. So I just have to type it in by hand. There you go. Right, and then we have the initializer. So if initializer is not equal to null, if let sum init equals initializer, body is equal to statement block statement, and it's just going to be statements, which is the back of init and body, and then we return body. All right, it compiles. Should we try this? This prints the first 21 elements of a Fibonacci sequence. Let's see what blows up. Cargo run fib 21. Ooh, okay, we already failed. Is it possible for us viewers to ask Pretzel Rocks which is the current song? I don't have any chat bots or anything like that. I think there's a way you can make Pretzel Rocks put that in chat automatically. I've seen it on other people's streams. I don't know how to do that though, or at least not off the top of my head. Let me see if there's some instructions online here. Pretzel Rocks. There should be a way to do it. How do I show what's playing on my stream overlay? Right track info into file? Yeah, I don't know. I'll have to play with it. I'll have to play with this and see. But I think there's a way you can make this just put the chat message, or throw in a chat message, and I don't know how to do it off the top of my head. I'll look into that off stream and see if I can get that to work. Okay, so this failed. So let's start debugging. First of all, let's figure out why this is telling me line 0 error expect expression instead of, is that in the parser here? Expect expression. Oh, because I always put 0 here. We should say what line we're on. And how do we do that? With peak, right? Okay. So let's fix that. Let peak equals self peak. Doop. I'm just copying these lines here, and then we can just put parse error and give it the token of peak. All right, now let's see what line is failing. Line 4. At close. Greenblade, thank you for the follow. Cat-n bib. So it wasn't able to parse this as an expression. So I must have done something wrong here. Which line? Oh, maybe it's looking for another semicolon or something. Let's take a look at the parser here. Maybe I translated this wrong. Because I think it must be doing this line here, right? And that would be, yeah, it's right here. Increment is equal to expression. Data number says, have you used GDB with Rust? I have not. I have not yet used GDB with Rust. We could try it. But I think what's happening here is we're calling this, and this is returning an error because it's unable to parse the I think it's right there, right? Oh no, it finished. So what's it, where is it dying here? Is there another expression that I messed up? That's the other expression, that's the other expression, and that's somewhere else. I mean, it says line 4, right? So we're here. Oh, I missed the consume. I missed this consume. That's what it is. Okay. And where does this go? So right after the increment. Right here, and just before the body. There we go. Okay, that checks. And it still fails. Oh, God. Did I put that in the wrong spot? Oh, I did. What's I doing? Oh, look at that. It runs. We got a for loop. And we have the first 21 numbers of the Fibonacci sequence. Including 0, I guess. I thought, yeah. I thought it didn't. I thought it was 1, 1, 2, 3, but maybe it is 0, 1, 1. Maybe it starts with 0, 1 and then goes 1, 2, 3. Okay. That's neat. So we have for loops working. A few chapters from now, when Lox supports first-class functions and dynamic dispatch, we technically won't need branching statements built into the language. Show how conditional execution can be implemented in terms of those. Name a language that uses this technique for its control flow. That's not really something I want to dive into, but basically you're using you can use dynamic dispatch to call different methods depending on what objects you've created around them. So the if becomes part of the interpreter rather than part of the language. Name a language that uses this technique? I don't know. I don't know of All right, number 2. Likewise, looping can be implemented using these same tools, provided our interpreter supports an important optimization. What is it and why is it necessary? Name a language that uses this technique for iteration. I think what they're getting at here is lazy evaluation, right? So like in Rust, if you can create an iterator, but the iterator actually doesn't do any work until you actually start using it, right? And at that point, it only goes as far as it needs to. And I think that's the important optimization, right? Because if you want to create a list of a billion numbers, you don't want to have to store them all in memory and iterate over them. You just want to create them one at a time. I think that's what they're getting at here. Unlike Lox, most style languages also support break and continue. Okay, add support for break statements. Syntax is a break keyword followed by a semicolon. It should be a syntax error to have a break statement appear outside of any enclosing loop. At runtime, a break statement causes execution to jump to the end of the nearest enclosing loop and proceeds from there. Note that the break may be nested inside other blocks and if statements that also need to be exited. Oh, how would you do that? Now, adding the parsing for break is one thing, but I think as you're interpreting it, you have to keep track of the current for loop, right? But then you could be like nested pretty far down inside block statements, calling if statements, calling while loops, calling all that, and then you can hit a break, and you have to pop up to the nearest enclosing, and in this case it would be the while loop. So somewhere, I guess, in the visit while statement, you'd have to store some data here, or have some information here saying, okay, we're entering a while, so the next break statement will come here. You'd have to pop out its execute somehow. That's an interesting thing to think about. How would that... Would you have to... I think what you would have to do is come back up here and change and return an error. Not an error, right? It wouldn't be an error to do a break, but I guess maybe we'd have to refactor this into a Lox abort or a Lox something. And then that would end up allowing us to do a break statement just by saying, instead of saying return okay, we'd say return error, Lox abort, break, or something like that. But then we'd also have to say have a Lox abort error to handle all our error stuff. I think that's the only way to do it. And then when the while loop executes, we'd have to say, if this is, is equal to LoxError break, or Lox abort. Abort's the wrong word, right? Break. Then everything's okay, but we just return out of the while statement at this point. Okay. I guess we have to match, right? It would be something like this. It would be okay. Otherwise, there would be a Lox abort error E, which would just be, oh yeah, so even simpler. If is okay. Let result equals. And then if it yeah, and then if result equals Lox abort break, then return okay, else return result. and that would be the other. Right? Or can we just break out of this? Because this is implementing a while loop inside Rust's while. Yeah, and we could just return OK or return result that way. And then if once this goes falsy, we return OK. Greenplay said, what is the question mark for at the end of some lines? I'm not very experienced with Rust. So Rust has this result type. I'm not sure what was triggering that Zeta numbers. Okay, sorry, but yeah. So Rust has this result type where the first half of it is separated by a comma here, and actually this is not a good one to look at. This is a better one to look at. We can either return an object, or we can return an error, and it has these two enums. Okay, is one of them, which returns an object, and then error. Let's find one. There we go, which has the error return, like that. So depending on what you return will be a result. It'll be an object if it's okay, and a LoxError if it's an error. What the question mark operator does is it says if this results in if calling this function here, self-evaluate x per left, for example, results in an error, then just return that directly. Just return that directly instead of continuing on. So it's syntactic sugar. We were just talking about sugar, right? So this is saying, this first line here would be the equivalent of saying if let error e equals self-evaluate x per left, then return error e, otherwise carry on. So it's just basically saying that. And actually saying let left equal, oops, right, because we're assigning left. If let, I guess it would be match this, right? If it's an error, E, return error E. Otherwise, if it's okay, O, okay, then give up the okay to the left statement. So that's what this line is doing this. And it's kind of a yeah, I mean it makes the code a lot cleaner, right? Otherwise I'd have to do one of these for every place where there's a question mark. I'd have to do it. And then also it's also useful inside of, I mean, you can put the question mark anywhere. I'm just looking for question marks now that are inside of other things, and I can't find them, of course. Maybe in the parser. Oh, Francistown, thank you for the follow. I missed that. Parser. Yeah, so for example, here I've got a question mark inside this statement's. I'm creating this new block statement object. I don't think they're called objects in Rust. And I'm calling self-blocked, and I've got this little question mark thing here. So this would have to do the same thing, right? It would do the match on the return, and either return the LoxError or just destructure that OK into a statement and put that into the statements. Oops. Anyway, so that's what that was doing. Now thinking here, I think maybe we could just say if statement body is because we're executing the whole body, and this body could contain many statements, one of which is a break. Should we try this? It might be possible to do this. Oh, the entire for loop was just in the parser. We didn't change any other thing. So this is all the for loop code. And we look for the for. We pull out the initializer, condition, and increment. We build up the body here. And then in reverse order, we'll deal with the increment. The condition gets a while statement, and then the initializer. And that's it. Oh, and then we fixed this thing so we could actually see what line we were failing on. Okay. Was this 9.5, I think? 9.5. 9.5. For loops. Yeah, let's just try real quick before we get into whatever the next chapter is. What's the next chapter? Functions. Before we get into functions, let's take a look at break statements, because that would mean refactoring the error stuff to make different error types, which might be good because right now I'm just sort of shoving things in here for error, parse error, and runtime error, and maybe we should have one for each, right? Oops, maybe it should be pubinum lox result. Maybe that's a better term for it, and then we can have parse error, which contains a token and a message. And that way we don't have to deal with these option tokens, right? And then a message of string, I guess. And then we have runtime error. Which also takes a token and a message. Oh, but these take lines as well. Yeah, we don't need to separate out the line, right? Because it's in the token. Like that. And then, but this generic one had no token, so generic error. And we'll have to look and see where that's done. I'll call it LoxError. And this has a line number, so line usize. And it also has a message string. Right? And then if we're going to add break, we can just add it as a type here. I'm not going to do it now because we'll get the warnings all the time. So if we refactor it like this, this becomes a lox result. We're going to have to change them all in our generator and everything. Epic Blog says, do you see any opening for introducing Rust into your day job, or will it remain plain C for the foreseeable future? Yeah, so the kernel work I do is all in C. There's userland work too that happens, and some of that could definitely be Rust. And actually I do use Rust for some things in my day job. But just like little tools that I write for myself, just so I can keep practicing Rust. Something that would be probably easier to be done in Python. But I play with it in Rust for my excuse is, I want to make it faster than what Python can do. So it's got to be a fast tool. Epic Blog says, I'm looking to rewrite some kernel modules in Rust as soon as the Rust for Linux project stabilizes a little more. Yeah, I've been looking at that too. That'll be exciting to work in. So instead of this, what we're going to do is say lox result, colon, lox error. Right, this is the syntax, yeah? And then line is line, and message is message to string. Oh, right, and then we want to report the error. And that's what this is all about. So let's make this a private guy. And then we're going to do the same thing here. This is going to take a little while to do, but the other lines will be, other code will be pretty straightforward, right? So this will be lox result runtime. Oh, parse error. And it'll be token dupe, and we don't need the line anymore. And there, that's that. Okay, that was easy. Zeta number says, I wonder what would be the first module in a Rust for Linux. I thought there was already Rust Next. I thought there was already something. I mean, this is from December. That's fairly recent. Oh, so it's just added support. Jesus Christ. Why do the websites do this? I'm just trying to read the article. Yeah, so they've added support. I don't know if they've added any modules. Officially, right? I mean, I'm sure third parties can write their own Rust modules once that support is in there. Okay, so then this becomes a LoX result runtime error. Like that. Right, and now that broke everything else. So let's fix everything else before we break it. Oops, let's put this here. Okay, we'll fix that later. Source, interpreter. So every time there's a LoX error, I'm going to change that to a LoX result. I'm doing it one at a time because I don't know if a global search and replace will break anything. All these look reasonable. We still call LoxError runtime error, so it's actually LoX result now, right? So that changes. Okay, and then in our generator, we also have to change it. Right, LoX result, LoX result. Okay, let's see what broke. Oh, an environment, okay. Oh, wow. Oh, right, the parser. I forgot about the parser. I just did the interpreter. I think a global search and replace would work, actually. Let's try it. LoxError, LoX result. Yeah. Okay. Oh, this is LoX result. We're down to 7. 6. Oh, okay. So now token, we don't know, right? So this is a report, and line. It's either going to have a line number or a token. So we want a generic report function that can handle whichever. Oh, Gustavo, thank you for the follow. Oh, and of course we have, I forgot to add this as a spammer. Oops. Oh, sorry, Greenblade, I missed. You said, do you personally prefer Rust or C? Well, I've been doing C a lot longer, so I feel a lot more comfortable in it. But I like Rust because it has a lot of features that make C risky. It fixes a lot of things that make C risky to use. Svenma, thank you for the follow. All right, so I think this is pretty straightforward. We could just get the line number pretty simple. We could say a line is equal to match on the types, right? Self. If it's a parse error, token message, or token underscore, and return token line. The same thing with runtime error. Can you do this? Will this work? I don't think so. I'll try it. And then the other type is a LoxError, which has a line and a something we don't care about, and that becomes a line. Come on. And that way we don't have to worry about this here. We'll just say line. Right? So that fixes that part. And then this here, we're going to say well, let me see first if this works. Oh. You have to do it this way. Oh, message. Parse error. It's right there. It's saying not found in the scope. Really? It's right here. Oh, because parse error is already. You can't disambiguate between the two. Okay. Standard string parse error exists, so we have to add it here. No, that wasn't it. How can you not find... What am I doing wrong? Oh, thank you, Zeta numbers. Okay. I'll get rid of these loxes then. We'll still call it lox result, but we'll call it 3x. So lox result parse error. Lox result error. Okay, so now we have a different thing, yeah. Token, this is usize. That's usize. Okay, so we can start that maybe. There we go. Okay, so this actually works. It looks kind of ugly, but it does the trick. It destructures the token. Thank you again, Zeta numbers, for the perhaps lox result. So I just renamed it from, the reason I'm calling it lox result is because I want to add also the break statement here that we'll use for the while loop. So it's not always an error. So that's the reason I've switched it from LoxError to lox result. And now we can't destructure the token. Lox output. Lox output, is that a good one? Because it's not generating output. Yeah, let me leave it this way for now, and then we'll see if it makes sense to change it. The other thing is we need to get the token. So if there's a token type, which is going to be the parse error or this guy, so maybe this guy changes. Right, you can do this token message here, token message, and deal with it this way. And then say if token is this, then do this, token is string, get rid of that guy. Otherwise, we're going to just print this. And we don't need to actually let line anything. Right? Self message because we just destructured it anyway. Okay, so it didn't like something I did here. Maybe I need to wrap this here. Token dot line. Okay, and then we have e-report, private associated function. Oh, okay, so what I should be doing... Result types are usually result type alias with your error type. Yeah, but like I said, once I add the break in, you're right, Zeta, but once I add this break in, it's no longer an error only. And now that I think about it, yeah, maybe there's a better way to do that part. But we do have this scanner report, so we need to just create an error this way. Which would already have been generated, or already been printed when we did this. Okay. We have an error here now. Oh, because I didn't break it. Which doesn't exist anyway, so I don't care. Okay, so we do have 4 warnings. Yeah, break is never used. That's okay. Oh, wait. Lox result. 2 warnings. Yep. Okay. So we're good. We're good. I think we're clean here, and we can still generate warnings and errors, and we should still be able to run this fib thing. Yep. And now if we want to add a break statement, what if we add a break statement here and say if A is greater than 1,000, break. And now it shouldn't compile. It's saying on line 8. Oops, I should say cat-n. Why didn't that work? Expect open. Oh, because I'm still programming it in Rust here. I forgot Lox requires these guys. Okay. And now it should complain about break. Yeah, undefined variable break. Okay. So let's see if we can add that. Generate. And now we'll create a break statement. Oh, this doesn't contain anything. That's probably going to blow up my generator. Yeah, option unwrap at none value. This is the first time we have a statement which doesn't take anything. Or maybe we don't have that as a syntax tree node like the for. No, we have to put something in there. All right. So what we can do now, it'll put a none in there, but that's not going to work, right? This should have at least built. Let me just put expert in here and see what happens. Oh, because I need a variable name. Yeah. That's what it is. Okay, but now it has this pub and none. I guess I can just, for now, I can just say option usize. Well, we should fix this code to handle. Okay, so now we don't have a visit break statement. So what happens in visit break statement? It's going to Lox result, and all it's going to return is an error Lox result break. There. And now here we're going to say if match this is equal to error lox result break error E, return error E. Otherwise okay, anything, do nothing. Right? Oh, and we're ignoring a statement. We don't care what the statement is because there's no data in it that we care about. And now we have to generate the break statement in the parser. Oh, we have to add it to the tokens. Nope, token type. There we go. Break. Right? And then we're going to get an error saying that's not constructed. So in the parser, we look for here, right? If self is match. And we can just shove it in here, right? Return okay. Statement break statement. And it contains, I got to, again, figure out a way we can create an empty struct. Right? Oh, an option. I guess we don't need, it doesn't need to be an option. Oh, no, it still says undefined variable break. Oh, because the scanner needs to be updated, right? Yeah, here. I forgot about that part. Oh, and we need to consume the semicolon. Self consume token type semicolon error. Oh no, expect after break statement. Okay, one more try. Yeah, okay, so that worked. It broke at that point instead of going all the way up to 6,000 whatever. But we do have an error that if I just say break, it doesn't complain that there's nothing to break out of. So I wonder if that means we need to keep track of inside an interpreter. We have to keep track of our nesting level, and every time we visit the while statement, we have to increment the nesting level. Greenblade says, in your day job working on kernels, do you also use a Mac for your work or Linux? I also use a Mac. I have a work Mac. This is my personal laptop Mac that I'm running on right now, but I've got a work Mac that I work on. Although it's mostly used for just logging into lab machines and running code there. I don't actually run my new kernel stuff on the Mac. So I think what we need to do is create a nest. We have to make it a use size so we can make it and do the interior mutability, and then say if we could just say nest borrow mut plus equals 1, like that, and then minus equals 1 when we return here. And if there's an error, I don't think we care about the nesting, although we do need to reset it to 0 if there's an error. Right? So where would that happen when we interpret? I guess say nest borrow mut equals 0. No, it doesn't like that. Self nest, right? Oops. There we go. And then down here, self. And we have to create one. Nest. F cell new size 0. There. And I'm sure there's something I'm forgetting to do. And then here we have to say if nest self nest is less than 0 or equals 0. Error lox result runtime error. Ooh. What we're missing is a token now. So that means I do need something in the generator to save the token for the break statement. But what token are we saving? I guess the semicolon? Peak is go self peak dupe, and then we can create the token here, right? Token will that do the trick? And then over here we can just say statement token break outside of while for I guess else. Why is it like that? Because that's a ref? Can I just do this directly or no? Yeah, expected reps. Okay, so borrow. Can I deref it that way? I can. Can I use the deref operator? Instead. Oh, I'm in the wrong file here. Didn't realize I switched. I use standard ops deref. Oh, so you still need to put a star there. Okay. I have 2 warnings. All right. So that should clean that up. So now I think if I say cargo 1 and just give it a break statement, break outside of while for loop, but it should still work if I say run here. Yeah, all right. That does the trick. Wow, that was a lot of change. Oh, only because we had to refactor all of that. git and generate source, git commit. What are we doing here? Refactored LoxError to Lox result and added a break statement. Okay. When you design your own language, you choose how much syntactic sugar to pour into the grammar. In the stream acrid end are those with ruthlessly minimal syntax like Lisp, Forth, and Smalltalk. Yeah. Near these languages, C, Lua, and Go aim for simplicity and clarity over minimalism. Some like Go deliberately eschew both syntax sugar and the kind of syntactic insensibility of the previous category. Somewhere in the middle, you have Java, C#, and Python. Eventually, you reach Ruby, C++, Perl, and D. I haven't used D before. Languages which have stuffed so much syntax into their grammar they're running out of punctuation characters on the keyboard. Yeah, talk to APL about that one. Syntactic sugar has a bad rap among the programming language, like SPL, Intelligentsia. Striking the right balance, choosing the right level of sweetness for your language relies on your own sense of taste. All right, let's dive into functions. I have about a half hour left, so I don't know how far I'm going to get with this, but we'll see. This chapter marks the culmination of a lot of hard work. The previous chapters add useful functionality in their own right, but each also supplies a piece of the puzzle. We'll take those pieces, expressions, statements, variables, control flow, and lexical scope, add a couple more, and assemble them all into support for real user-defined functions and function calls. You're certainly familiar with C-style function call syntax, but the grammar is more subtle than you may realize. Calls are typically to named functions like average 1, 2. The name of the function being called isn't actually part of the call syntax. The thing being called, the callee, can be any expression that evaluates to a function. Well, it does have to be a pretty high precedence expression, but parentheses take care of that. For example, get callback could return a pointer to a function that you call. The name is part of the call syntax in Pascal. You can only call named functions or functions stored directly in variables. Okay, I forget the call syntax in Pascal. It's been a while. There are two call expressions here. The first pair of parentheses has get callback as its callee, but the second has the entire get callback expression as its callee. It's the parentheses following an expression that indicate a function call. You can think of a call as sort of like a postfix operator that starts with open parentheses. This operator has higher precedence than any other operator, even the unary ones. So we'll slot it into the grammar by having the unary rule bubble up to a new call rule. Okay. The rule allows star to allow matching series of calls like function 1, 2, 3. Code like that isn't common in C-style languages, but it is in the family of languages derived from ML. There, the normal way of defining a function that takes multiple arguments is a series of nested functions. Each function takes one argument and returns a new function. That function consumes the next argument, returns yet another function, and so on. Eventually, once all the arguments are consumed, the last function completes the operation. The style is called currying, after Haskell Curry, the same guy whose first name graces the other well-known functional language. Is baked directly into the language syntax, so it's not as weird looking as it would be here. Okay. So this rule matches a primary expression, followed by 0 or more function calls. That's the star that they're referring to up here. The rule uses star. So this star here. If there are no parentheses, this parses a bare primary expression. Otherwise, each call is recognized by a pair of parentheses with an optional list of arguments inside. The argumentless grammar is this. This rule requires at least one argument expression followed by 0 or more other expressions, each preceded by a comma. All right. To handle 0 argument calls, the call rule itself considers the entire arguments production to be optional. All right. So 0 or more of this. It's got a question mark in there. So the arguments themselves could be optional, but if there are arguments in an expression followed by any 0 or more commas followed by expressions. To handle 0 argument calls, the call itself will the entire arguments to be optional. Right, so question mark is 0 or 1. I admit this seems more grammatically awkward than you'd expect for the incredibly common 0 or more comma separated things pattern. There are some sophisticated meta syntaxes that handle this better, but in our BNF and many other specs I've seen, this is cumbersome. It is this cumbersome. So the generate code for the new node is in appendix 2, but we're going to just toss it in here. Okay. So under binary, we have call, which takes a box expr of callee, token of paren, and then a list, which is a vec of expr of arguments. Okay, it stores the callee expression and a list of expressions for the arguments. It also stores a token for the closing parenthesis. We'll use that token's location when we report a runtime error caused by a function call. All right, so in parser now, where unary used to jump straight to primary, change it to call. So this changes to call. And we're going to just put call. And it returns a result of expr or lox result. All right, this code would be simpler as while match left paren instead of the silly while true and break. Don't worry, it will make sense when we expand the parser later to handle properties and objects. Oh. Okay. Sure. This is another situation where we're going to do this expr thing, so we have to say mut expr is equal to self primary. And loop. Then expr is equal to self finish call. I guess expr like this, maybe? I don't know. We haven't written it yet. Else break. Otherwise return OK expr. So now we have to write finish call, right? The code here doesn't quite line up with the grammar rules. I've moved a few things around to make the code cleaner, one of the luxuries we have with a handwritten parser. But it's roughly similar to how we parse infix operators. First we parse a primary expression, the left operand to the call, right? Then each time we see an open paren, we call finish call to parse the call expression using the previously parsed expression as the callee. The return expression becomes the new expr, and we loop to see if the result itself is called. So that supports this business here. We get this, we have one, we get a closed paren, which I assume finish call is going to consume the closed paren. And then if there's another open paren, this becomes the callee to this guy. And then this becomes the callee to this guy. Okay, that makes sense. The code to parse the argument list is in this helper. Okay. And now we're passing in this callee as an expr. I don't know how that's going to work. Can I just do this? I don't know. We might have issues with this. This is going to be interesting how this is going to handle, how this is going to work. All right, let's find out. Let mut arguments is equal to vec new. If not self check token type right paren Then, ooh, we don't have do whiles in Rust, so we're just going to have to do arguments push self-expression. Right, and then we'll say while self is match token type, comma, arguments push self-expression. So we just have to duplicate that code in order to simulate the do while loop. Then we say let paren self consume and then we're going to return okay expr call expr, and let's pull that up real quick. I guess I have to use it this way. Call expr. Oh, we didn't write it yet. It's going to take a callee, which is this guy. This is where things are going to get a little weird, right? Callee is box. See, it's taking a box expr, but we're passing in a reference to an expr. So maybe we need to pass in the box. Oops. A box to it. So maybe that'll work. I don't know. And then paren, and then we need a right. It goes on the right. Oh, that's the arguments. I don't think that's going to compile. This is more or less the arguments grammar rule translated to code, except that we also handle the zero argument case. We'll check for that case first by seeing if the next token is right paren. And if it isn't, then we can go in here. If it is, we don't try to parse any arguments. Otherwise, we parse an expression, look for a comma, and we keep going. If we don't find a comma, then the argument list must be done, and we consume the expected closing parenthesis. Finally, we wrap the callee and those arguments up into a call AST node, right? And that's this guy. So I don't think this is going to work, but let's try building it. Oh, right. Let's just put a stub in here for now. Expr dot token. Oh, paren. I think it's called token, right? Not. Oh, we can just say to do. Get it done. That's probably the easiest thing to do. Oh, right. This needs to be one of those. Yeah, okay, so we have expected a reference. Expected a box, and we found a reference to a box. Oh boy. And I don't think I can do this. I mean, I'll try it, but I don't think that'll work either. Oh, it is paren. So what was it complaining about then? Oh, found enum result. That's what it was complaining about. This needs to be boxed. Yeah. So here's the move thing. So what's the best way to handle this? What's the best way to handle this? Because we definitely want to push the expr down. Greenblade says, what do you use for the file picker in NVim? I've got FZF set up, but I find it's quite slow. Yeah, that's what I'm using. I hit Control P and it's pulling up whatever that is. I can actually, hang on, let me pull this up and I'll throw this in chat as well. This is what I'm using for my setup. I made some tweaks to it, but basically it's ToggleBits setup with a few minor adjustments. And then if you want FZF, you have to install the FZF package, but I'm just hitting Control P and getting this list. Yeah, so how do we generate call exprs? This is where I'm going to get stuck for today, right? Because in Java, we're just passing around a reference, right? And so we have a reference floating somewhere in the ether, and we pass that around, and that gets shoved into. Should we make that a reference? I mean, that might be the simplest thing to do, right? I don't know how well that's going to play with other things, but we can certainly make it a reference. That's not hard to do, and then we can just clone it here. We will need to add so it makes it a little more complicated because we're not using references anywhere in that guy, but we are using it now here. Because if I change this to RC, right, now we're going to have to include RC. But that'll get shoved into this guy as well, and then we'll get warnings about RC's not used. Which I guess we can clean that up later. Okay, so that worked. Yeah, we're not using. That's what it's complaining about. And visit call expr is not. That's because we haven't written it yet. So this might do the trick, but I want to clean up the other thing first. So in here, maybe I can cheat. Like this, and then I can say if I is equal to RC, then it's writeLin file use standard RC else. That's kind of hacky. But it works. And then in our interpreter, we're not using this. Okay, so that cleans up all those errors and warnings. But now I'm thinking, should I, instead of all those boxes I have in there, should I make them all RCs? Because I got boxes everywhere, but does it make more sense to do RCs? And I'm thinking yes. Let's finish out this function thing here. Let's at least be able to call a function. How hard could that be, right? So maximum argument counts. Right now, the loop where we parse argument has no bound. If you want to call a function and pass 1,000,000 arguments to it, the parser would have no problem with it. Do you want to limit that? Other languages have various approaches. The C standard says a conforming implementation has to support at least 127. If you're writing code that takes 127 arguments, you need to rethink your lifestyle, I think. I'm just making that blanket statement. Don't at me. It doesn't say there's any upper limit. The Java spec says we can pass in no more than 255. Limit is 254. If the method is an instance method, that's because this works like an argument that is implicitly passed. Okay, so it claims one of the slots. Our Java interpreter for locks doesn't really need a limit, but having a maximum number of arguments will simplify our bytecode interpreter in part 3. We want our two interpreters to be compatible with each other, even in weird corner cases like this, so we'll add the same limit to JLocks. All right. Note that the code here reports an error if it encounters too many arguments, but doesn't throw the error. Throwing is how we kick into panic mode, which is what we wanted. The parser is in a confused state and doesn't know where it is in the grammar anymore. But here the parser is still in a perfectly valid state. It just found too many arguments. So it reports the error and keeps on keeping on. All right, so in our parser, in finish call, I guess we can take a look here. If arguments .len is greater than greater than or equal to 255. Greenblade says, what is your stream schedule? I stream generally every weekday, Monday through Friday, from 7 a.m. to 9 a.m. Eastern Standard Time. Or Eastern, now it's Daylight Savings Time. East Coast, US. I will, once in a while, I'll take a day off if I can't stream for that morning or for whatever reason. And then sometimes I would go on vacation. I don't stream then. But generally, I try to stream and then I upload all the VODs to YouTube just because. Oh, Zenzeus, did I miss you? And Svenma, I didn't hear sound for those. I apologize for missing out on the follows. But thank you, Svenma, and thank you, Zenzeus, for following. If you're still here. Hopefully you're still here. Apologies. Epic Boy says, when I first started using C, I wrote a 2E library without knowing about structs. I had 20 plus argument functions and thought there must be a better way. And that's how I learned out about structs. Yeah. There's got to be a better way. Yep. Okay, so... But that's pretty impressive, writing a 2E library. Just out of the gate, knowing C as a beginner. I like that. So we're going to generate the error, but we're not going to throw it. So we're going to just say LoxError. No, LoxResult. Oh, now I forgot what I call it. Error. And we're going to report the line. Oh, I guess it's a runtime error. You can say runtime. Because we're doing the peak thing. Right? And we can just say peak, and then say can't have more than 255 arguments. But we keep doing it. And I guess else. They don't have an else in there, but I'm going to put an else. The other thing we need to do is record the error, that the error occurred. So because that's something that we had to do a slightly different way to the way they did it. The only thing that's bothering me now is that if there's a 300 arguments, we're going to see one of these for every single argument that's over 255. So maybe we'll just not report it if not self-had error. We'll do it this way, so we only see it once. I'm not going to test it, but that should work, right? Yep, at least it compiles. So interpreting function calls. Okay, now we get to the fun stuff. We don't have any functions we can call, so it seems weird to start implementing calls first, but we'll worry about that when we get there. First, our interpreter needs a new import. Oh, I only have 15 minutes. I don't know if... Yeah, maybe I should wrap things up here and then tomorrow we can do this. Because if I start this now, we're going to be in the middle of something when I have to stop. And it won't be because it looks like we're making an interface, which means we have to think about how to do traits again. I guess we could put this code in, right? Let's start with this. We do have 15 minutes, so interpreter is a call. So this is this. So let call e is equal to self-evaluate expert call e. Oh, now that's a problem, right? Because evaluate takes an expert, so it's an RC. So do we have to do a borrow here? Oh no, or a deref? Well, let's see what happens. Let's do a build. Oh, and let's just say okay, object. Oh no, it took it. Okay, so the fact that it was a RC versus a box didn't matter. Good. Let mut arguments was vec new for argument in explore arguments argument push self-evaluate argument. Oh, maybe we don't have to put that there, question mark. And then we have this lox callable, which is going to be an object type, right? So we have this object type. So we're going to have to create this new lox callable. It's something in here. What goes in here? Should I call this function? And inside call it callable? And then down here we can say if let func callable or function equal to call e. Right? Then we can say function.call. So it takes a call thing, this, which is self, and the arguments. Else. I guess it's a runtime error, right? We need the expr paren for the token, right? Calling. Actually, this is probably not a runtime error. This is probably a panic. Call e did not destructure into a function. That means the parser did something wrong if it didn't generate a function, or the interpreter did something wrong. And now we need to create this callable. Let's put it here temporarily. And it takes something we can call on. So pub struct callable. Except this is a trait. But let's not go there just yet because I'm almost out of time. Pub fun call, and this takes a self, which is is an interpreter. So terp interpreter and arguments, which is a vec. Arguments vec of what? Of objects. And it returns a result of object or lox result. Right, I'm just wanting to do this here. And for now, we're just going to return OK object no. And see if it builds. I think I need to import this. This is going to go in a separate file, but just for now, I just want to get it to see if I can get it to build. What did I do wrong? Functions are not allowed in, oh, pub struct callable, right. Impl callable. And results, so use create. And func is not found in object. And we still have 4 errors. In this macro, callable cannot be formatted. Oh, okay. That's easy to fix. Derive, debug, clone, and partial. And it's still not good. Oh, now we have to be able to print out a function. Okay, object. Actually, probably do it in the same order, right? Func. Right, bang, F, func. We'll just do that for now, but I'm sure we'll have function, more detailed function info. Ooh, look at that. We do have 4 warnings, and that's because these things aren't used. What's the last one? A variant is never constructed. So this needs to be constructed from somewhere. Black Udon says, I never quite understood why you use older editors like Vim. Well, I'm a very old, so this is what I grew up on. And it's one of the things I like about it is I don't have to use the mouse, right? I can do everything just from the keyboard. So I don't have to move my hands off the home position. Everybody's happy. But look, I have I use Sublime Text actually for part of my day job. You know, half of text editing is done in Sublime Text. So I use that too. But you use what makes you feel most comfortable, and you use what makes you most productive. And that's the way I see it. If you like it, use it. If you don't. Greenblade says, I'm 18 and I love NeoVim. Good. Yeah, you gotta find what works for you. If you don't like it, it doesn't mean that it's bad for somebody else, right? It just means that it doesn't work for you, and you got to find something that works for you. Black Udon says, I switched out editors over the years from Notepad all the way to VS Code. VS Code is awesome. I love people watching streams of people who use VS Code, but this is not me. Also, this makes this display for streaming very simple. I have the browser on one side and the text edit on the other side. If this was VS Code, it would be something here where I would be having VS Code. Maybe pretend this is a VS Code window, right? And I'd be doing like this, and I'd have to tab like this back and forth, and blah blah blah. So having Vim is very minimalistic. There's nothing on the left and right. If you notice, I don't even have line numbers turned on. A lot of people have the line numbers turned on, and the relative lines going, negative this way and positive this way. Epic Blog says, I use Edlin because chest hairs. Yeah. There's also an editor, I don't know if it exists on Mac OS. Yeah, ED, which is like even more basic than Edlin. I can't even escape from it. There. Oh, I killed the wrong one. What was I doing? Can we recover whatever I was doing there? Oh. What was it? Oh no, we're good. Oh no, we're not good. Hang on. Yeah, there's no save file. Okay, we're good. We saved everything we were doing. So we still have 2 warnings. That's because we're not constructing this, which is fine. That's what we're going to do tomorrow. So I'm not going to push these changes yet because we're still in the middle of doing this. And it looks like, oh yeah. Okay, I'm gonna toss this in real quick because this is what I added just to make it compile. But let's visit call expr. Let's just use the same thing here, and we'll just say error, LoxError, runtime error, and we're going to use expr paren. And the error is can only call functions and classes. Right? And that should Oh, I missed this. And Lox result. Yeah, Zeta numbers. I think I'm gonna run into a lot of problems. You mentioned doing Lox output. I don't know. I'm second guessing my Lox result thing here now. Okay, so that's this, and then checking arity. Okay, that's what we're gonna do tomorrow. We have this cargo. Yeah, let's do clip E real quick. I have 1 minute. Good. Okay, so I'm not worried about that. Git status. Git add generate and source. Git commit. What NVim plugin do you use for auto formatting? I think I just have it set to save or format on save or something like that. I forget. Yes, I just set this value here, and that did the trick. So hopefully. There must be some other plugin that activates that, but I don't know what it is. But once I set that, then it turned it on. And that was a tweak I made to toggle bits thing. Okay, are we good? Good. Commit -m beginning of section 10.1. Working on partway through function calls. And I'll push this up and everybody will be happy. Thibit, thank you for the follow. Even modern plain Vim distros have Rust support with support for G-Rust format autosave equals 1. Oh, good. Good, so you don't even need any plugins for that. Sweet. Okay, so meanwhile, back at the pottery barn, I'm going to wrap up this stream. I believe that for the first time ever, Brookalizer is up before 9 a.m. So we're going to go raid his channel, or their channel. Sorry. He's starting soon, and he's doing Rust and U, or he has been doing Rust with U, Y-E-W. So that'll be interesting to see. So I'm going to set the raid up for him. Thank you everyone for hanging out with me. I appreciate it. Enjoyed all the feedback and comments. And I hope to see you tomorrow where we hopefully finish up functions. All right, take care.